Okay, so for lesson 10.5, we're going to look at other angle relationships in circles. My joke, what part of a circle do you use to tie a package? What part of a circle do you use to tie a package? And my videos have been getting longer and longer, so I'm going to try to pick up the pace today. We have 3 new theorems. The first is, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. So that means that to find the measure of angle 1, it's half of the measure of arc AB, and to find the measure of angle 2, it's half of the measure of arc ACB. Okay, so that means that what could happen is they might give you the arc measure and ask you for the angle measure. To figure out the angle measure, that's going to be 1/2 the arc, or 66 degrees. Or they might give you the angle measure and ask you for arc measure EFD. In that case, you're going to want to do 2 times whatever that angle measure is, and in this case, it's 220 degrees. All right, the next theorem says that if 2 chords intersect inside a circle, where the intersection point is on the interior of the circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle at its and its vertical angle, of course, is the same. So if you want to know the measure of angle 1, it's half the sum of arc DC plus arc AB. And that would work with measure of angle 2 also. It's going to be half, I might mark this, so angle 1 is half of the sum of these two, and angle 2 is half of the sum of these two. So BC plus AD. Alright, so let's see how that plays out in, actually we're going to go to the next theorem. These theorems do get kind of difficult to all keep straight, which is why you're going to be allowed to make a cheat sheet for your test. It is kind of hard to keep them all straight. Although one of the things I was thinking, here I go getting longer again, is that when you look at this, a circle is 360 degrees and a line is 180, so it kind of makes sense that it would be half. And here, one of the things that I think about is that it's the mean, it's the average of the two, because when you add 2 things and divide by 2, that's the average. So the measure of angle 1 is the average of these 2 arcs, and the measure of angle 2 is the average of those 2 arcs. That might help you. Here's the last new theorem for today. If a tangent and a secant, or 2 tangents or 2 secants, that's kind of a lot of different possibilities. You can have a tangent and a secant, you can have 2 tangents, or you can have 2 secants that intersect outside the circle. So notice their intersection point is in the exterior in all 3 cases. The intersection point is in the exterior of the circle. Then the measure of the angle formed is half the difference of the measure. So before we had half the sum, now we're going to do half the difference. So if I want to figure out the measure of angle 1, I take 1/2 of the big arc, BC, minus the little arc. And in this case, if I want to find the measure of angle 2, it's half the big arc minus the little arc, or the major arc minus the minor arc. And in this case, same thing. We're going to do half of this big arc minus this little arc. Okay, so what does that mean? When we look at the last theorem, 10.12, remember we said that it's the average. So if you want to find the measure of, if you want to find x here, based on the chords, x is going to be half of this angle, FJ, or this arc, excuse me, plus this arc. So half of the measure of FJ plus GH. And so that's half of 112 plus 140. And I'm going to add another line here. 112 and 140 is 252. And then we have half of that is 126. And since we're just looking for x, you don't need a complete mathematical sentence. You don't need a label. It's just 126. Now, that was when they intersected on the interior. The point of intersection is on the interior of the circle. So it's half of the sum. Now we have the point of intersection on the exterior of the circle, and so it's going to be the difference of the two. If I want to find the measure of angle FGH, if I want to find x, I'm going to take this big arc, which is JF, minus the little arc, HF. So that's 170 minus the 72, and 170 minus 72 is 98, and half of 98 is 49. Again, you can just stop at x equals. Now, this is really going to help in terms of saving time. We're not going to do this example, and we're not going to do this example. So here we are at the checkpoint, and you can go ahead and pause. You're looking for the measure of this arc, complete mathematical sentence. You're looking for x, and you're looking for y. So just x equals, y equals. Go ahead and pause. Okay, hopefully you had enough time to pause and enough time to do this. Here we are with they give you the angle. And remember that the angle is half of the arc. So the measure of arc ACB is just going to double it. So it's 240 degrees. So no work to show, but a complete mathematical sentence, yes. Now, if we want to find x here, I've got some information. If I want to find x, notice that 52 degrees is pointing to this angle. So what I would need, if I want to find x, it involves this arc and either this angle or that angle. So what I'm going to do is realize these are a linear pair, and 180 minus 52 is 128. So the measure of that angle is 128 degrees. So what I know then is the measure of the angle is equal to 1/2 times the sum of these two, because the intersection is on the interior. Now there's two different ways you could solve this. You could distribute the 1/2, or you could clear the fractions first and just multiply everything by 2. If you multiply by 2, you get 256 equals the 144 plus x. That gets rid of the 1/2, and then when you subtract 144, you get 112 equals x. 112 equals x. In this case, the point of intersection is in the exterior, so we want to talk about this angle, which is 26, is equal to 1/2 times the difference. So I want to take the big angle, which is y, minus the, big arc, minus the little arc, which is 30. Again, I could distribute, or I could multiply through by 2. If I multiply through by 2 and clear the fractions, and then add 30 to both sides, we get 82 equals y. So, the answer to the joke, what part of a circle do you use to tie up a package? A cord. You use a cord to tie up a package like a ribbon. Alright, this might be my shortest video ever. I hope it helped.